Welcome to the tutorial for Sustainability and Ecosystem Health, Week 5 Feedback Loops and Adaptability. In this tutorial, I will outline what a feedback loop is and give examples of both positive and negative feedback loops in an ecosystem. I'll present examples from case study carving up a national icon, the Florida Everglades. Within complex adaptive systems, such as ecosystems, for example, bushland, river systems, catchments, or lakes, there are many variables responsible for the change within the system. These variables are responsible for creating the dynamics of the system. These variables can be the volume of a component or how often changes occur. For example, how much grass grows in a grassland, the volume of sediment entering waterways, nutrient loads within sediment, or the available sunlight within a system. The output or result of a system's variable is in part fed back into the input. A feedback loop is described as the sequence of changes that occur to the system. These changes can occur from other components of the system. Feedbacks are the linkage of change in a system. They can have a positive feedback, which has a promoting effect on the system, or a negative feedback, which has a dampening effect on the system. These linkages are responsible for the dynamics or functioning of the system. All complex adaptive systems have an interwoven network of different positive and negative feedback loops. These loops are responsible for maintaining the system's dynamics and preventing thresholds from being reached, resulting in regime changes. They also have the ability to absorb shocks to the system. Changes to variables can be from an external source, for example, climate, demands, or various human-driven impacts, such as policy, development, etc. They can also be from an internal source, for example, availability of resources, growth, population sizes. These directly affect the system's ability to maintain stability. Positive feedback loops in general are responsible for the instability of a system. The counterbalance to this is that of negative feedback loops that return the stability to the system. Combined, they form a very important function of regulation. An example of a positive feedback loop that is well known is that of climate change. The warming of the atmosphere has a feedback effect that will encourage even more warming. This is brought about by the increased water vapour from the initial warming, therefore completing the loop effect. Another example of such instability because of a positive feedback is an introduced species of grass reducing the ability of native plants to grow. The introduced grass increases the likelihood of bushfires in that area. After the fires, more introduced grass will grow as a result, creating the linkage or positive feedback loop within the system. Firstly, an example of negative feedback loop is that of herbivore fish on coral reefs. Changes within marine ecosystems such as reefs can result in seaweed inundation. The fish will eat the seaweed, reducing its volume, providing a dampening or negative feedback that provides the stability to the system. Another example of a negative feedback loop is that of aquatic plants' ability to provide a dampening effect in waterways. Stormwater runoff emanating from agricultural, residential lands can contain higher levels of nutrients. The plants in turn absorb the nutrients from the water, dampening the effects the excess nutrients can have on the system. External impacts because of social growth and development have had a significant impact on the Florida Everglades. Human-driven changes can push a system to the edge of a threshold, and even beyond the threshold, from which it may never restabilize to its original regime. In case study carving up a national icon, the Florida Everglades, human impacts on feedback loops are evident. Development of infrastructure, agricultural lands, residential developments, and industry have all impacted the dynamics of the feedback loops within the system. Former naturally wide plains of the Everglades provided the system a negative feedback loop. During the wet season, the lake floods. Prior to human-driven impacts, the area's wide marshland would have slowed the flow of the water and dampening its impacts. Dry season in the Everglades also provided dampening negative feedback, demonstrating the interwoven nature of feedback loops. The dry season shrinks the waterways and concentrates the aquatic life into deeper sections, thus providing the positive feedback of an abundance of food for predators. An example of positive feedback within the Everglades is that of the volume of high in nutrient concentration sediments. The shift in grasslands from sawgrass vegetation to cattail was as a result of agriculture pushing the system into a new regime, from which it will take considerable effort to recover from. The maintaining of interwoven connections of positive and negative feedback loops is integral to the ongoing stability of a system. Shocks or changes to the edge of thresholds can make a system vulnerable and reduce its resilience to variables. In order to help a system maintain its current regime, an understanding of what feedbacks exist, both positive and negative, is required. Then encouraging, nurturing, and ensuring maintenance of these critical feedbacks will provide stability and longevity to the ecosystem. This concludes the Sustainability Ecosystem Health Feedback Loops and Adaptability tutorial. The examples of feedback loops presented are only the tip of the iceberg. The more research of feedback loops, the more it will unveil their vast interwoven connection within complex adaptive systems around you. Thank you.